Okay, so today we're going to look at the transposition of formula. Now, some of you, or all of you, would have met this in your maths so far, or if you've done physics, you may have met it in that. And before we start, what transposition form or formula is essentially just moving around the items in an equation or a formula to make what you want to be the main focus of the formula on its own on one side. Now, some of you who've done physics, you will know that you've used triangles. Now, I don't like this method. Now, the reason why I don't like this method is it's only ever useful for items when you've got three unknowns, and that apart from that you can't use it. So if you've done stuff before using triangles such as this, you're more than welcome to remember it, but please don't use it. It is not useful. Okay, so moving on from that slight bugbear of mine, we're going to just look at transposing formulas which have the form something like V equals U plus Ft over M. That's a formula, but we're also going to be told what we want as the subject. Now, the subject is just the thing that's on its own on one of the sides. Now, we normally say the left hand side, but it doesn't have to be, it could be the right hand side. So in this case we're going to make F the subject. Okay, so how are we going to go about this? Well, we've got our formula. We want to make F the subject. So we need to move the things around in this formula so that we've got F on its own. Now remember, when you're doing equations, whatever you do to the left hand side or the right hand side, you have to do to the other side. You can't just do it to one side, it has to be done to both. So sometimes you might find it's easier to move, say, the term with the F in it, or with the thing you want to be the subject, onto left hand side. Especially if it's negative, it will make it positive, but in some cases you might not. But you can do that with practice and work out which one's best for you. Anyway, back to our question. So what we're going to look at in this case is that we're going to try and move the things. The order of the way we move things is to move the things which are furthest away from the thing that we want as subject, the letter we want as subject first. Now, in this case, on the right hand side where the F is, the thing that's furthest away is this U. So we need to move that. We need to get rid of that. So if we take U away from both sides, you've got V minus U equals Ft over M. Okay, so it's getting a little bit clearer. We've got less terms. We've only got now 3 terms on the right hand side. I would say the next one, which is furthest away, is this M here. So let's get rid of that. And how are we going to get rid of that? Well, we're going to times both sides by M. Okay, so you've got M as M times V minus U equals Ft. And then we're just left with this T. I'm going to get rid of that one by dividing both sides by T. So we end up with M V minus U over T equals F. And at this point we could just rearrange this so that F is on the left, and it's only for looking nice that we would do that. There's no real actual value in it. So we've got M V minus U over T, and this is our solution. We've made F the subject of this equation that we had at the top here. Right, well, if you can do that, let's go on to a slightly more difficult equation. When I say slightly, a little bit more tricky, very tricky. Okay, so let's say we're given that d over c is equal to the square root of f plus p over f minus p. Oops, that bracket's not meant to be there, it's meant to be over the whole thing. Okay, so we've got this equation. It doesn't look nice, and we're told that we want to express it, or express p in terms of the other letters. So basically this phrase here means that we want p as the subject. We want p on its own on one of the sides. Now, looking at this equation, the main stumbling point when we start off with is this square root, because it covers all of it. We're looking to try and get a p, one of these p's, on its own, but we've got a square root here. So how are we going to get rid of that square root? Well, why don't we square both sides? So we've got d over c squared equals just f plus p, f minus p. And if you know your indice rules, which hopefully you do, you know that d over c squared is the same as d squared over c squared. So we can put that on that side, and these three are the same. Okay, the next bit is when you have a fraction which has both an item which you want as the subject in both the top and the bottom. And what we're going to need to do here is cross multiply. Now, cross multiply basically just means that we're trying to get rid of all these bits which are on the bottoms of these fractions. So we're going to times the left hand side by this c squared, and we're going to times the right hand side by this bit on the bottom, here the f minus p, and that should get rid of both the denominators, both the bits that are on the bottom. So there's, say, if we take that in stepwise, if we times both sides by c squared, we end up with f plus p c squared over f minus p equals d squared, and if we times by f minus p, the reason I'm writing it twice here is because to remind myself that I'm doing it to both sides, not just to one side. We end up with c squared times f plus p equals d squared f minus p. Now you'll also notice that here I have the c squared at the end, and here I have the c squared at the beginning. Now it's outside the bracket. It doesn't matter whether it's afterwards or before. Both have the same meaning. Both mean that this whole bracket is times this item over here. So if it's before or after, it doesn't matter. Normally in general nomenclature, the way we write equations, should I say, we would write it at the front here. And you've met that probably more often than you have with it afterwards. But to be honest, if it was the front or the back, it just means it's times by everything that is either before it or after it. Okay, so we've got that here, and it may not look like we've made it any more simple, but essentially we've got rid of fractions now, and that makes it easier. So what we're going to do when we've got this situation is we're going to try and times it out, because essentially at the end of this whole calculation we're doing, we want f's on one side, things with f's in on one side, and things without f's on a different side. So let's times both sides out here. So we have c squared f plus c squared p equaling d squared f minus d squared p. You can see we've got two terms which have f in it, and two terms which don't have F in it. You should be able to rearrange those so the F's are on one side, and when this time I'm going to put them on the left hand side, and all the terms without F's are going to be on the right hand side. So we would end up with c squared F minus d squared F. Remember, when it's coming over, you're going to take it away from that side, so we take it away from this side, will equal minus d squared p minus c squared p. So just in case you haven't got that, that's c squared f minus d squared f equals minus d squared p minus c squared p. Okay, so in these two terms we have a common factor. We have something which is in both, and that's the f. We can factorize out. So if we take it out by factorizing, we end up with sf times by a bracket which inside it has c squared minus d squared. And we can in fact do the same for this side. It has a factor of p, so we could make p come out and it'd be minus d squared minus c squared. Once we've done this, then we know we've just got two terms here. We want f to be the subject, remember, so we're going to divide by the other part that's here. So f will be equal to p minus d squared minus c squared all over c squared minus d squared. And that's your final solution. Now, going back to where we had this point here, and I took this and took the f's over to one side, to the left hand side, and I put the p's onto the right hand side. We didn't have to actually do that. We could have kept the f's on, put the f's on this side, and kept the p's on this side. And if we do that instead, then we end up with c squared p plus d squared p equals d squared f minus c squared f. Again, we're going to put all the f's on one side and all the p's on one side. That's what we've just done. And we're going to factorize out the common terms. So p equals c squared plus d squared, p times c squared plus d squared equals f d squared minus c squared, and so f will equal p c squared plus d squared all over d squared minus c squared. In that case, that's our solution there. So if I write that down next to this one, we've got f equals p c squared plus d squared over d squared minus c squared. If we look at these two, they must be the same because f equals that. And the only difference between this one and this one is that if I times the top by minus 1 and I times the bottom by minus 1, I'll get to here. And equally, if I times the top by minus 1 here, I'd get to that. If I times the bottom by minus 1, I'd get to this. So they are exactly the same, and they are both correct. There is not one which is better than the other. They're both correct. And so even if, let's say, you get a slightly different answer to the person sat next to you, as long as it is only because you've rearranged it slightly differently, it can still be correct, and that's worth noting when you go through this. Okay, so let's go to an engineering question. Okay, so we're told, or I know, that the impedance of an AC circuit, is given by the equation, and impedance is Z, is given by the square root of R squared, its resistance, plus X squared, which is its reactance. What I want to do is I actually want to rearrange this to make the reactance, and I want to make that the subject. And I would like you to pause the video and have a go at doing that, and then restart the video and I will go through how we've managed to do this. Okay, so very similar to the one we just did, or the one I just went through with you. We're going to square both sides to get rid of this square root. That square root is the most difficult bit because it's the bit that stops us from separating these two items. They're joined by the square root. So let's square both sides. So Z squared equals R squared plus X squared. The impedance squared is equal to the resistance squared plus the reactance squared. And we've got to remember what we're trying to make on our own. We're trying to make X on its own. So let's move the items that aren't X onto the other side of the equation. So Z squared minus R squared equals X squared. And then we don't want it squared, we want it just as a single X, so we're just going to square root both sides. So the square root of Z squared minus R squared equals X, and you're done. Okay, so hopefully through this video you've got a better understanding of transposition formula. There are some additional questions which I've put on the Moodle page which you're more than welcome to have a go at. If you have any problems or any questions, please ask, and we'll try and make sure that you can do this. Cheers.